I'm going to start explaining the simplest, or the first, probably easiest gas law. It's called Boyle's law. And what it does is it compares, or it looks at how pressure and volume affect a gas. Now, gas laws are a big deal in chemistry and physics. Gases, we've been working under the assumption that 1 mole of a gas equals a volume of 22.4 liters. And we had a little condition on that. And the condition was at something called standard temperature and pressure. And standard temperature and pressure was a temperature of 0 degrees Celsius, and the pressure was 1 atmosphere. Well, if I sit there and I change those conditions, this equality of 1 mole equaling 22.4 liters of a gas no longer holds. So that is what Boyle's law is all about. Boyle's law looks like this: P1 V1 equaling P2 V2. Now, another way to look at that would be that pressure, when multiplied by the volume, is going to equal a constant. But this is kind of the form that you take to solve problems with most often. P being pressure, V being volume. So here's how this whole thing's going to work. Okay, let's say I have, and gas laws usually you can pretty much figure out why they work the way they do. Let's say I got this fancy little gizmo, and it's kind of got a plunger. It's kind of like a French press coffee thing. Okay, so I got this little thing that I can push down. And initially, let's say I have, some molecules of gas in there. Now, those gas particles are going to be moving because they're at some temperature. They have kinetic energy. So they're going to be dancing around in there, moving this way, that way, just in this random kind of deal. And every once in a while, well, not every once in a while, but quite often, they're going to hit the side of the container. Okay, they're going to hit there, all over the place, and just keep hitting and hitting and hitting. Well, that's going to result in a pressure being exerted by the gas, and that's how we describe a pressure. It's collision of gas molecules with the side of the container, side of you, whatever, but that's where the pressure is coming from. Now, if I take this plunger, okay, and this time I squish it down even more. How come I lost my pen? Where am I writing? Okay. I squish it down. I took the plunger and I pushed it down a little bit farther. Now, with the same number of, how many did I have? I had 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, with the same number of gas molecules, so I haven't changed the number. Okay, I've kept the number of gas particles in there constant. Oh, that was the problem. Get rid of that. Now what's going to happen is these guys at the same temperature, because they have the same kinetic energy, the same motion, they're going to be hitting the sides of the container more frequently. More frequently means that they're going to exert a greater pressure. So if pressure here, for example, was equal to 1 atmosphere, pressure 2 here would be equal to, and I'm making this up, but maybe 1.5 atmospheres. Okay? Because I squished down the volume, these guys are going to sit there and start hitting the sides of the container more frequently. It's going to exert a higher pressure. Well, I can figure out what these volumes were. If that was indeed how the pressure changed, and let's say that the initial volume of this container was 500 milliliters, I wonder what this new volume would be, is equal to, so I'm kind of answering that question. So what I do simply is take Boyle's law, pressure at one set of conditions, which would be the 500, or the 1 atmosphere, times volume, which would be 500 milliliters, milliliters is going to equal this new pressure, P2, times some volume, V2. And I'm going to set it up. I'm just going to solve it. I'm going to plug numbers in. So I have 1 atmosphere for P1. I'm going to multiply that times a volume of 500 milliliters for the volume 1. That is going to equal P2, which is 1.5 atmospheres, times this new volume V2. So solving for V2 is going to equal 1 atmosphere times 500 milliliters divided by 1.5 atmospheres. Okay, and you know, the atmospheres are going to cancel out. When it's all said and done, I'm going to end up with 500 divided by 1.5. I'm going to end up with a volume of 333 milliliters. Okay, 333 milliliters. So that answer right there is what this new volume was going to be. Okay, so the key to this is realizing that there is a inverse relationship between volume and pressure. Okay, so what I mean by that is if pressure is increased, volume must decrease, or vice versa. Okay, so pressure is inversely proportional to volume when we're talking about gas laws. All right, I don't think I need to. Now this only works, Boyle's law only works when temperature and number of moles is held constant, meaning I'm not changing those. Okay, now the rest of the gas laws are going to deal with changes of temperature and constant and moles, and we'll talk about that in the next one.